Hello everyone. In this video, we're going to be solving a nice system of differential equations. X and y are functions of t, and we have the following equations. Y double prime plus y is equal to x. X double prime plus x is equal to t. And we're going to be solving this system. All right, let's go ahead and take a look. First of all, we're going to start with the second equation. Since the equation only depends on t, there's no y in it, we're going to start with that one. So this is actually a linear, non-homogeneous, ordinary differential equation. So let's go ahead and take a look at this. First, we're going to check the homogeneous case, which is x double prime plus x equals 0. Obviously, we're going to first solve the homogeneous case, and then we'll find a particular solution and go from there. So if you look at the characteristic equation, if you remember how we did this before, you're going to be replacing x with something like e to the power rx, actually rt, that's what I meant, x equals e to the power rt, and then by plugging it in, you're going to realize that our characteristic equation is as follows: r squared plus 1 is equal to 0. Now from here we get two solutions, and those solutions are r equals plus minus I. Since the solutions are not real, and remember, we're going to write this as an exponential, solutions are going to be like e to the power it and e to the power negative it. But of course, we're going to be looking at a linear combination of these. So in other words, using the trigonometric version, we can write our homogeneous solution as a times cosine of t plus b times sine of t. Okay? Now let's go ahead and continue with this part. Now here we do have actually a forcing term, which is the polynomial t, right? So in order for that, I'm going to try a particular solution as a linear polynomial in t, which is at plus b. Now, obviously from here, we're going to take the first derivative, that's going to give us a, and then the second derivative is going to give us 0. So if you substitute this into our equation, we're going to get 0, which is the second derivative, plus the original expression, which is at plus b is equal to t. Remember, we have t on the right-hand side. From here, we basically get that a is equal to 1 and b is equal to 0, which means our particular solution is going to be t. Now, if you put the homogeneous solution and the particular solution, you're going to be getting the general solution for x, which is a cosine of t plus b sine of t plus t. Great. Now, this is going to be our solution for x. And guess what we're going to do to find y? Can we just substitute this? Sure, why not, right? Now, let's go ahead and substitute this expression in terms of x. So we get y double prime plus y is equal to a times cosine of t plus b times sine of t plus the t. Now, here we kind of have like three terms that do the forcing, which means we don't have, we have a non-homogeneous equation again, but we have different kinds of functions. We kind of need to find a particular solution for each one of them. So for example, if you wanted to find, let's say, y double prime plus y is equal to 0, let's start with the homogeneous case. As you know from before, the solution for this homogeneous case is going to be something like c cosine of t plus d sine of t. Now, how do you do the forcing for each case? Let's start with t since it's kind of simple. So now let's go ahead and just consider this equation. Suppose we only had t as the non-homogeneous part. So here we're going to try at plus b again for the y particular, and a and b are disposable, so don't worry about the values here. We're going to get the second derivative, and that's going to be 0. And then from here, we're basically going to be getting the same thing. So a is going to be 1 and b is going to be 0, which means our homogeneous solution for y for this particular forcing is just going to be t. But that's only part of the equation, okay? Let's go ahead and find something for the a cos t part. So we're trying to solve now this piece, y double prime plus y is equal to a cosine of t. But cosine of t is already a homogeneous solution, right? So in this case, the undetermined coefficient method is not going to work. So here's what we're going to do instead. For the particular solution for this one, we're going to try something like a kt sine t. Okay? Now, why does this work? You'll see in a little bit when we take the derivative. The first derivative is going to give you k times sine t plus t cosine t. And when you differentiate this one more time, you're going to get k times cosine t plus cosine t minus t sine t. Okay, from the product rule, obviously. And of course, you can simplify this. Y double prime of the particular solution is then going to be k times cosine of, I meant 2 cosine of t, 2 cosine of t, and then minus t sine of t. Now, let's go ahead and add these two together. Y particular double prime and y particular, of course, I'm talking about the second particular here, is going to be k times 2 cosine t minus t sine t plus k t sine t. And guess what this is equal to? This is equal to 2k cosine of t, which means if you set it equal to a cosine t, obviously that's what we had on the right-hand side, from here we get 2k is equal to a, or k is equal to a divided by 2. Now this coefficient is important because we're going to write our particular solution, the second one, as a over t times t sine t. Okay? Now let's go ahead and try the third piece of the equation. So now we're going to try y double prime plus y is equal to b sine t. And for this one, and you can see from here that the particular solutions we have to assume has to be different every time. That's why we can't combine any of these. So I'm going to now this time assume something like kt cosine t. And then I'm going to do the differentiation and add them together. To keep a long story short, you're going to get the yp double prime. Of course, this is the third case scenario. Is going to give us the following. K times negative 2 sine t minus t cosine t. If you do the derivatives, that's actually pretty straightforward, by the way. You're going to be getting from your after simplifications negative 2k sine t. And of course, in this case, we have to set it equal to b sine t. So from here we get negative 2k is equal to b, or k is equal to negative b over 2. That's going to be another coefficient just like this one. And of course, the third piece of our particular solution is going to look like this. Negative b over t multiplied by t cosine t. Now here we have to keep the negative sign. We cannot really absorb it into the constant because a and b kind of work together and they come from the problem that we were trying to solve. Okay? Great. Now let's continue with the rest of the problem. Let's put it all together. Now is a good time, I think, to combine everything so that we can write the solution. Remember, from the homogeneous equation, we had c cosine t plus d sine t. And then we got the t for the t. And then for the cosine t piece, we got a over 2 t sine t. And finally, minus, which is this piece, b over 2 t cosine t. That will be the solution for y, the general solution, right? And then for x, if you remember, x was, and of course you can write this as a function of t if you want, like y of t and x of t. X was much simpler, right? A cosine t plus b sine t plus t. And you can definitely verify these by introducing into this equation. And you're going to realize that actually, if you plug these in, they're going to satisfy both equations simultaneously. And this brings us to the end of this video. Thanks for watching. If you enjoyed it, please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care, and bye-bye.